Guys, in this video we are going to see how to change the order of triple integrals, and also we are going to see when we change that order of triple integrals how it's going to change the limits of integrations. Now let's look at the possible orders. Now first we can do the integration respect to z first. If we do that, we can have dz dx dy. Also we can have dz dy dx. Now we can also do the integration respect to y first. If we do that, we can have dy dz dx, or we can have dy dx dz, and also we can do the integration respect to x first. So if we do that, we can have dx dz dy, or we can have dx dy dz. Now let's start from this one. Okay, we are going to do the integration respect to z first. When we do that, we have to think like shooting it's better to think like shooting a bullet from negative z-axis, right? And it depends on which integration you are doing first. If you are doing respect to y first, you have to think like shooting a bullet from negative y-axis and reaching here. And if you do respect to x first, you had to think like shooting a bullet from negative x-axis and through from negative x-axis to positive x-axis, right? Now here, since we are doing respect to z, we are going to think like shooting a bullet from negative z-axis to positive z-axis. Now where it's going to hit first, that's going to be our lower limits of integration, and the region where it's hitting is exactly on the surface. For example, here we have this plane, like this surface is exactly on the xy plane, right? So that's going to be 0. If it's exactly on the xy plane, that's going to be 0. Also you can see, if we do the integration respect to x first, it's going to hit this surface. This surface is exactly on the zy plane, so this is also going to be 0. The lower limits is going to be 0. But let's look at dy. If we do the integration respect to y first, if we draw a bullet line like from negative y-axis to positive y-axis, this is not going to hit exactly the surface, because this surface is not exactly on the xz surface, right? So the lower limit is going to be different. Now since we are doing dz, we are going to look this one later. Now let's look at z. For z, it's hitting exactly the xy plane, right? Plane surface. So this is going to be 0. Now let's write our integration. So lower limit is going to be 0, and upper limit is going to be where it's going to hit last. And if you look at this one, this is going to go through this one, and this is our roof, right? Z is equal to 1 minus y, that's our roof. So it's going to hit this one last. That's going to be the upper limits of integration. And that should be in terms of z, and it's already in terms of z, so we can just directly write 1 minus y. And this is going to be the limits of integration for z. Now after that, we are doing the integration respect to x. Now after we do the first integration, we don't have to look at 3D diagram anymore. We just have to write the 2D, we just have to draw the 2D diagram, and then we have to decide our limits of integrations. Now let's go ahead and draw the 2D diagram. Now we are only considering xy plane because we have taken care of z plane, z axis. Now we only have to deal with xy plane. So I'm going to draw the graph in terms of x and y, right? Now from this one, how to draw the graph? You can flip this graph around. It's already here, right? You can flip this around, or you can think this equation, y is equal to square root of x, and that graph looks like this. Right? And the region we are interested in is this region. If you look at this one, this part is blank, so this one we don't worry about. This one we only take care of this part, because this is the region, this one, right? And it's starting from 0 ending at 1, because it's ending at 1 here, so this is 1. Now if we want to take the integration respect to x first, we have to draw a horizontal line. And if you want to take the integration respect to z first, then you have to do the line vertically. Okay, since we are doing the integration respect to x after z, we had to do the horizontal line, and this horizontal line starting from 0, because this line is x is equal to 0 and it's ending at the here. the equation of this line is given by y is equal to square root of x. It's here. Okay, so this is y is equal to square root of x. Now if we do the integration respect to x, we have to write this one, this is something like x is equal to, but this is y is equal to square root of x. But if we want to write x is equal to, we have to square both sides, so we will get x is equal to y square. So y square is going to be the upper limit of integration. Now let's look at the last part. Last part we are going to do the integration respect to y. For the last part we only look at the starting part and ending part. So this is our y-axis, this is our x-axis. For y it's starting from 0 and ending at 1, right? So that's going to be the limits of integration, 0 and 1. Okay, now that's it for this one. Now let's move to the next part. dz, dy, dx. dz, we already seen the limits of integration. This is going to be same thing. So we can just copy that one down, 0 to 1 minus y. That's our dz. Now after that we are going to do the integration respect to y after this one. So when we do respect to y, we think this one like we have to draw a vertical line. Here we are going to have a vertical line, and we have to see where is this vertical line starting. And if you look at this one, this is starting from y is equal to square root of x. It's already in terms of y, so we can directly write this one, y is equal to square root of x, and it's ending at 1, y is equal to 1, right? So upper limits of integration is going to be 1. Then after that we are going to integrate respect to x. Now we have to see where is starting at x and where is finishing at x. By the way, this one intersecting at 1 comma 1. Okay, so this one is also 1, so it's starting at 0 ending at 1, so this is going to be 0 to 1. So this is for this one. Now let's look at this one, dy. And if you do the integration respect to y, first we had to draw a bullet. We had to look at for the first integration we had to always look at the 3D diagram. Here we have our 3D diagram, and we had to think like when we do y first, we had to think like a bullet, shooting a bullet from negative y-axis. And if you think like that, this is going to hit this surface, but as I mentioned before, this surface is not exactly on the xz plane. So we had to use this equation, y is equal to square root of x. That's going to be the lower limits of integration, right? So let's write the integration. Okay, first we are doing respect to y. So square root of x is going to be the lower limits of integration. Now let's look at upper limits of integration. So we have to see where it's going to hit last. And if you look at this one, when we consider y, this is going to go through this one and you're going to hit this roof, right? This roof is given by z is equal to 1 minus y, but we have to have this one in terms of y. So if we rearrange this one, this is going to become y is equal to 1 minus z. Okay, that's going to be the upper limits of integration, 1 minus z. Y is equal to 1 minus z, y is equal to square root of x. Now after that we are going to integrate respect to z. Now in order to do that we have to draw the 2D diagram. Now let's get rid of this part. Okay, now 2D diagram for, so we have taken care of y, the only thing left is x and z. Now for this one, x and z is this surface. You can see this is like a curve, but you have to project this one in the xz plane. Like easy way to think is if you flash a light, like if you have a light, for example, let's say we have a light in this side, and if you have this light, where is the shadow is going to form? How the shadow is going to form? So if you think like that, you can draw the graph. That's going to look like this. Okay, and also if you can see through the equation, like we are going to have z is equal to 1 minus y, and we know that y is equal to square root of x. And if you see this one, 1 minus square root of x, that graph look like this. Okay, and this one is 1, and this is our y-axis, this is our z-axis, and this is our x-axis. Okay, and this is starting 1 and this is finishing, this also 1. Now we're doing respect to z, so we have to look at the inside of this graph. So for z, if we want to do this one respect to z, we have to draw a line vertical. Okay, and it's starting from 0 and ending at this graph right here, that is given by z is equal to 1 minus root x. So this equation is going to be 1 minus square root of x. And the last one is we are doing respect to x. So for this one we only look at the starting and ending part, starting from 0 ending at 1. So this is going to be 0 to 1. Okay, now let's see how it's going to change if we have dy, dx, dz. For dx it's going to be same thing, we already found it. I mean for dy it's already same thing, y is equal to square root of x, y is equal to 1 minus z. And for dx, if we want to do respect to x, after this we had to draw a horizontal line and starting at 0 and ending at z is equal to 1 minus root x, but we have to write this one in terms of x. We have to have something like x is equal to something, right? So this is square root of x 1 minus z, that is dy. Now we are doing dx after this. Now lower limit, that's going to be 0, but for the upper limit we have to rearrange this one in terms of x because we have to have x is equal to something. So if we rearrange this one, this is going to be square root of x is equal to 1 minus z, therefore x is going to be equal to 1 minus z whole square. So this is going to be our upper limits of integration. And the last part is we are going to do respect to z. For this one we have to just look at starting and ending part. It's starting at 0 and ending at 1. So that's going to be just 0 to 1. Okay, now we have done this part. Now let's look at dx, dz, dy. Now let's get rid of this part. Okay, so for the first integration we had to look at the 3D graph. We had to think it like, since we are doing respect to x, we had to think a bullet coming from negative x-axis, okay, and going through the positive x-axis. Now we have to think where it's going to hit first, and that is hitting this zy plane, and this surface is exactly on the zy plane, so that's going to be 0. So 0 is going to be the lower limits of integration, and the upper limits of integration we have to see where it's going to go through. And you can see this is going to go through y is equal to square root of x, and we had to have something like x is equal to, right? So this is y is equal to square root of x, and if you write this one in terms of x, x is going to be equal to y square. So y square is going to be the upper limits of integration. Now after that we had to do this one respect to z, and when we do respect to z, now after we done the first part, we had to go through the 2D diagram. Now let's draw the 2D diagram for this one. Now we have taken care of x-axis. Now we have to have only z and y, right? Z and y. That's easy because we can already see it's a triangle. So we can just draw a triangle, and we know that here it's 1 and also 1. So this is 1, this is 1. Now if we are going, this is our z-axis and this is our y-axis. Now if we are going to do z first, we have to draw a vertical line, okay? And the equation of this one is z is equal to 1 minus y, and this is starting from 0 and ending at this line. So starting from 0 and ending at 1 minus y, 1 minus y, okay. And then we have, after that we have dx. For dx we just look at starting and ending point, actually not dx, dy. We just look at starting and ending point, start at 0, end at 1. So that's going to be the last limits of integration, 0 to 1. Okay, now let's see what happens if we have, this is this one. Now let's see dx, dy, dz. dx dy dc, exactly the same graph. So this is for dx, that's going to be 0 to y square, 0 to y square, that's dx. And then we are going to have dy. Now to find dy, we draw a horizontal line, and that's starting from 0 and ending at this line. And now for this line we have to write this one in terms of y. So y is going to be equal to 1 minus z. So that's going to be the upper limits of integration, 0 to 1 minus z. And the last part we just look at where it's starting and where it's ending. So z is starting at 0 and ending at 1, 0 and 1. So this is going to be the limits of integration for this part. And that's how we change the order of triple integrals, and that's how the limits of integrations changes according to the order. I hope this helps. Thanks for watching.